Let's set up AWS console. Sign into console. Continue with the root user. Root user password. Multi-factor authentication code. Okay. So guys, try to recollect EC2, Elastic Cloud Compute. It's nothing but on that server, we have to take the server with proper operating system, RAM capability, hard disk, and then on that we need to install our Java and then run our Spring Boot application. Okay, so we already discussed that. EC2. So we need to take a proper OS plus RAM capability plus core capability. Some hard disk will be taken. On this one, we need to install Java, and we need to deploy our payment validation service there, and then accordingly use it. Okay, payment validation service, accordingly use it. So we can just go from this shortcut place. EC2. We need to be careful. Everything, choose it in the proper same region, because region to region, some different connectivity setup might be required. So whatever you create, RDS and other thing, everything should be under the same region. Let's say AP South 1. Okay, fine. Next, go to instances. Currently, there is nothing here. Launch instance. Let's say we put a name to this, Feb 26 CT server. We need to take an image of what OS you want, to Amazon Linux. And yes, 2023 kernel 6.1. This is what we want. 64-bit. And whatever is available for your free tier, you choose the free tier machine from here. Currently, it is suggesting, depending upon when you open your account, they might give you different machines. So choose the free tier one. Okay. It is giving me 2 CPU, be RAM related machine right now. Okay, fine. Whatever is offered to you, you choose that one. Next, in order to connect securely to this EC2 machine, we need a key pair. Last time we already created a key pair when we were demonstrating EC2. So no need to create it again. Existingly created options will be available here only. Feb 26. Just see. Okay. What we created earlier, you can just choose it from the drop down. So for the first time when we are creating, then create new key pair. Second time onwards, you can choose it from the drop down only. Okay. So basically we are doing some selection, how the machine should be, which operating system, how much bit, core, memory, how to connect securely, what will be your secret key. It's already there in our local machine. Let's quickly verify. D drive, CT, data, AWS. And yes, the key pair is available here, so we can use it. If you forgot it, if you misplaced it somehow, then you have to again create a new one. Otherwise, you will not be able to connect to this machine. Okay, please be aware of that. Fine. Next, network. Click on edit. Let's see. Continue with the default VPC. No subnet preference, no availability zone preference. They will set it up properly. Auto assign public IP. Yes, we want it. Create a security group. Okay, let's create a new security group. What is security group? Firewall rules. When outside people, nothing but from our laptop, we want to call this service. So the configuration will be enabled in security group. Okay, so some naming will be there. Just see, by default, 22 port is used to connect and to copy. So it will always be enabled 22. Now, today we will be testing our validation service there. So validation service is running on what port, guys? Validation service runs on 8081. Let's enable 8081 also. So rather than going later and adding inbound rule, during creation itself, you can set up the inbound rules. So let's do it from here only. Add custom TCP, port is 8081, and from where do you want it? Let's say anywhere we want to allow this port to be invoked. That's the setup we are choosing. 8 GB of hard disk we are giving, and that's it. Okay. Chalo. Once it is done, then do a launch instance. So this is step number 1. Let's give it some time. It is going to process it. Instances. Let's go to this tab. Running state also, very good. IP is created, running state is there. Okay, very nice. So we did this activity. EC2 machine is set up. Okay, guys, are we clear with this? EC2 machine setup, we have done it earlier. It's a quick recap. Okay, nice. Shubham, Pallavi, very good. Yeah, I think some of you guys have already demonstrated it and shared it on LinkedIn also. So practically working EC2 setup. Very good. So EC2 machine is created. What are our next steps? So we need to connect to this machine and install Java. After that, we need to think about our application deployment. Please, let's complete this part first. So how do you do it? Mobaxterm and other commands are there for that purpose. So let's launch Mobaxterm. N number of softwares could be there. Whichever the developer is comfortable with, they use that particular software. Okay. SSH, start local terminal. Using SSH command, we can connect. You need to provide your secret key also, your PEM file which you got, a key pair. So use that, use the SSH command, and you can connect to the destination. Okay. SSH-I, then the secret, and then EC2 user, and then this IP what we got. Okay. So already that SSH full command is available here, something like this. -I, you need to specify a PEM file. The account machine is EC2. Okay. So what we will do is, let's fix this IP. Okay, let me change the IP. We already discussed, every time we start a new machine, it is going to have a new IP. If you want to have a fixed IP called as static IP, so we need to buy it separately using elastic IP concept. So you go to elastic IP, it is going to give you one static IP, and whenever your machine comes up, it can assign that static public IP for you. So by that way, you don't have to every time work with a new IP. So generally in projects, always elastic IPs will be set up. Okay, please be aware of that. So, but now it's okay to have this one. We go here and we paste it here, replace all. Okay. Let's see what is our, this is our command. Try to connect to this from Mobaxterm. Okay, do you want to connect? It's a new machine. Yes. Okay, done. Just see, Amazon Linux 2023. So now we are connected to AWS. This is no longer our local machine. This is AWS machine now. We can check it out, right? EC2 user. Okay, fine, clear. Let's say Java space version. Java command is not available here. So we need to install Java 17. So using this command, on this we can install Java 17. Let's try to check if the execution happens. Okay, it's searched and now it is installing. Okay, completed. Java version. Okay, it is there. Let's do an exit. Let's try to connect back again. Okay, fine. So Java version is 17 running. Okay, very good. Next. Now we have to do application deployment here. Again, but try to understand, when we are deploying the application, in the property file, it should have the changes to connect to these related places. So currently we have not done any of this setup. So we have to now move the focus into, before we deploy the application here, we need to have the setup ready for these guys also. At least we will go one by one. Initially, we will try to set up RDS. Then gradually we will move to Redis. And then gradually we will move to Secrets Manager. Okay, so step by step, let's do that. But our second focus is for deploying the Spring Boot app, we need to connect to other services of AWS dev environment. These other services include RDS, Redis, Secrets Manager. Okay. So first we will be doing setup of that. So let's try to do some setup of RDS. Generally, this takes some time to do, but let's start and eventually it will happen. So what can we do? EC2 is already up. Just search for RDS. RDS. Okay. Managed Relational Database Service. Okay. It is saying Aurora and RDS. So what is this Aurora? So AWS team has done something. Okay, they have made, okay. So if you are using some Aurora version of database, so that is given by AWS team, where database is now more faster than regular versions of that DB. For example, let's say we click on DB database, you click on create database. Just check it out here. AWS team has created Aurora, which is MySQL compatible, and Aurora, which is PostgreSQL compatible. So if instead of choosing these two, this is regular MySQL, this is regular PostgreSQL, they have taken those versions and they created an Aurora version of that, which is more powerful and more speed and more performance is going to come as part of these Aurora related machines. Accordingly, the pricing and costing is going to be higher side as well compared to these other guys. So depends upon your project need, okay, which one you want to use, but just be aware, you just have to choose this Aurora and RDS, then go to the database section, click on create database. Then you have to choose which database you want. Okay. And let's say for our testing, we are choosing our regular MySQL as the database. Depends on what you're doing in your project, you might choose whichever other database. These kind of options are available with AWS right now. So let's say you choose MySQL. The setup is very simple, guys. And please be aware, at junior level, people will not give you even login access to this AWS console. Okay. And even if they give it, only view only or very basic privilege access will be there. And nobody expects you to do all this setup also. Okay. So this will be done by one senior guy, because DB is a one-time setup activity. You don't do it every day. So most of the times, even with 2-3 years of experience, people might also not get this chance, unless it is a startup or very small scale organization. There you might get very big responsibility also. But anyways, for any mid-sized companies, big organizations, senior guys will do one-time setup. They might have DevOps guys who will be specialists into managing this AWS. They might itself do it, or senior members might do it. But as you grow more in your experience, like maybe 3 years, 4 years, definitely you should familiarize yourself with all these AWS related things also. So it is always a good to have skill along with your development skill. Knowing this AWS will be required as you grow more in your career. Okay? So for initial, it is fine even if you are not aware. Okay? But it's okay. Okay? Now the thing is, let's choose MySQL here. So I think we can just put down one point about that here. Initially, setup access of AWS will not be granted. This is most of the time scenario, okay, to entry level professionals, okay, mostly the seniors or DevOps will take care of this setup. But only if you are in small scale companies, in small scale orgs, you might get chance to do all this work, setup and everything. Okay. So, but your important thing should be, as you gain 3+ experience, start mastering even AWS. So you need AWS plus backend, both skills. Okay, fine. Now we are choosing MySQL, this one. What is our local MySQL database? What is our local MySQL database? Let's see this one. So generally what happens whenever you open a script file, which database it is running on, you can choose it from this drop down. Okay, which database it is working on. So currently it is in local host. We can simply select here, select version. Okay, so when you choose the version, it is saying 8.0.39. So similar kind of version, try to take it on AWS. Any 8.x version should be okay, but let's try a similar kind of version. Let's say 8.0.40, let's say. Okay, try to take a similar one. Next, generally these small version wise, there might not be any differences. Internal optimizations might be there at database level. Next, so what do you want? Just notice, what are we doing? Create a new database. You need to choose the database, MySQL. Next, choose what version of MySQL you want to use. Next, look at this part, very interesting. How do you want this database to be managed? Just check it out here. You want to have one primary and other two secondary, and that too in 3 different availability zones, AZ1, AZ2, AZ3, so that backup, restore, and proper safety, even if something goes wrong in AZ1, you still have your data at other places. Do you want this kind of a setup? Generally for production, people will choose something like this. Or do you want only one primary and one secondary? Okay, so accordingly, depending upon how much budget people want to allocate for these things, people will be taking care of that. Since we are doing some testing, you can just go ahead with a free tier related setup, and in that just one node is fine. When the work is completed, we can delete the machine as well. Okay, so please be aware, even though if it is free tier, sometimes RDS might do some charging also. So depending upon your usage of RDS, so better practice is, as soon as your work is done, delete the RDS system. Okay, so please be aware, we are choosing our 8.0.40 and then free tier, so we can experiment with it. Single deployment installation. Fine. Once you are done with this, let's move further. Give some name to this database. For example, we can say database dev. Okay, database of dev environment. So whatever is the projects, so payments project, payments, and then it's a dev DB, something logical which identifies about, let's say, whatever project you are doing, or you can say PIS, payment integration system, hyphen dev environment, hyphen database. So for the QA environment, you will create PIS hyphen QA hyphen DB. Okay, something like that. But anyways, that's a naming convention. It should just identify what this database is. You can follow whatever is convenient for you guys to remember what DB it is. So dev database we are going to have here. Okay. So if you remember DB conversation, we said one proper physical database we will install. Inside that, logical DBs will be created. So when you say dev database, here you will create 1 DB for validation service, 1 DB for processing service. So in the same database, for every microservice, one logical DB will be created. Right? Try to remember that conversation, guys. So one physical DB will be installed, and inside that, multiple logical databases will be there. And this is applicable for our dev environment. Similarly, for QA also, we will be having one physical DB, and then inside that, multiple logical databases. This is how the setup is going to go like. Okay. So guys, is this point clear? Team, is this point clear? How this setup will happen? One physical DB. Right now, we are taking that physical database, dev DB. In that, now you can create n number of logical database, one for every microservice. Okay, fine. Let's continue further. So sometimes it might happen that you have many number of microservices and you have many number of logical databases. Then we have to make a decision. Do we want to keep everything in the same physical DB, or more than one physical DB should be there? Okay. So depending upon how big the scale of the project goes, people might make decisions to further split also. That depends on project to project situation. But some kind of setup will be there. Please be aware of that. Okay, fine. Let's resume back. So here we go. Go back to the RDS. Give some name. Let's give some password also to this. The way when you install your database, MySQL, it also has some password. So here also we'll give some password, something which you can remember right now, you can give it. Fine. Security will be password based. Okay. All this, continue with the defaults. Defaults. No need to make any changes. By default, 20 GB you are allocating. If you grow this GB accordingly, like how much data you can choose, a 100 GB machine or a 150 or 200. So it depends how much configuration you are setting up. But yes, for testing, you can start with smaller itself. Maybe 10 GB is also fine. Anyways, continue with the defaults. Dekho, another important thing here is, do you want this database to be accessed from outer place? Nothing but from your local machine should this DB be connected. We had a similar conversation while EC2 we were doing earlier. So from local machine, if you want to access it, it has to have a public IP. Similarly, here you have to choose, do you want this database to be publicly accessible? We discussed earlier how exactly it will happen. While EC2 discussion happened last time, whenever we did it. Let's say you have a database and you want to access it from your local machine. Okay, this is our local machine. You want to access this. So one thing is, it has to have a public access. Okay, it has to have a public access. If it is not having public access, workaround is there. What is that? You can make this as a private. Okay, if you make it private, from your local machine, you cannot access it. This doesn't work. Then what do you do? Okay, only via some other software. Generally, people use the terminology as jump box. Okay, jump box. Or there is another term called as Bastion host. Bastion host. Something like this. Okay, let's see if I'm pronouncing it right. Yeah, Bastion host. These are all entry gateway software names. Okay, jump box or Bastion host. So you are expected to connect to this one. This will have a public access. So from your local machine, you can connect to this one. And from there, you can tunnel inside this DB. So then that works. So here if it is private, private means from outside nobody can access. Privately within the infrastructure, other services can talk to it. So private access means within the AWS communication can happen, but outside guys are not allowed to connect. So it completely depends how your project related setup is, but try to be aware how to connect to the database. You might need it for your testing also. Sometimes using public address you directly go, sometimes via this workaround solution is available. Okay, fine. So for now, we are not getting into these additional setups. Again, DevOps expertise will be required to do all of these additional work. Okay. So as a developer, we focus from how much we need to know about all these things. So here we go, and we will be choosing a public access. Continue with the default VPC configuration. No need to make any other additional changes. Just continue with the defaults. Okay. Database encryption on, backup turned on. So currently we don't want backup since it is only testing, so no need of backup. Enable encryption is fine. Enable auto mirroring, fine. Okay, remaining things are okay. Just turn the backup off as well. So once we do this, I think we are ready to do the setup. That's it. What did we do? Important things. Let's quickly look through this. RDS. We chose the RDS version, MySQL, then made it a free tier related DB. We set up our credentials and we have done public IP. Rest of the things we continued default. One thing we turned off backup, disable backup we did. Okay. Disable automated backup so that some cost saving can happen while you're doing the testing also. Okay. Once we are done with this, let's go ahead, create the database. We chose a simple password, so a reminder is coming. Generally, this will take some time to process. Okay, generally, sometimes it goes even up to a few minutes also, because DB related work is a lot of work internally, setting up OS and all that, whatever. So it might take a few minutes. RDS setup can take a few minutes. So meanwhile, let's continue with other activities. So once it is ready, then we will be reaching back to this RDS section. Okay, and then we will resume. But what have we done so far? EC2 is set up and Java installed. This is done. Step number 2, RDS setup in progress. RDS setup in progress. And next we have to do is RDS. We need to run DDL and DML script. So this will be our next work. Okay, RDS, DDL and DML script. Next what? Next what? We need to set up Redis. By the time this comes up, then we will move into this other side of changes. Now we need to do setup of Redis, because currently when our Spring Boot application is coming up, it is trying to connect to Redis somewhere. Okay. Now let's quickly look what configurations of Redis we need. Localhost. Now think about it from this perspective, guys. This is important. Again, it is basic and it is important. Everybody should have 100% clarity on this. What localhost mean? When you run your Spring Boot application in EC2 machine, if there you are saying localhost, it means in this EC2 machine, your Redis should be there. So localhost will keep changing depending upon where the machine is. Okay. So in your local machine, if you are running a Spring Boot application and you say localhost, it means your local machine. If we run the Spring Boot application on an EC2 machine and there you say localhost, means you're talking on this EC2 machine, it has to be there. Guys, is this point clear? The localhost is contextual word. So when you run it in your machine, you call it localhost. When I run in my machine, I call it localhost. When we run it in AWS and we call localhost, means it is AWS EC2 machine. Is this point clear, guys? Localhost is contextual. Your localhost means your machine. My localhost is my machine. Okay, Rutesh is clear. Others clear with this? Simple, right? Okay, Gaurita, Sabiha, Chandrika. Okay, very good. Now let's discuss further. How to do this Redis related setup in AWS. There are more than one ways, and AWS has the way RDS service. Try to remember Redis conversation which we did. Redis also needs to run in a cluster, nothing but not just one machine. The way database needs to have primary, secondaries, and backed up and all that, Redis also needs to run in a cluster. More than one services should be there. High availability should be ensured. Case it will not be a single point of failure. All that, there are two options. Either developers, you take care of manually doing all that, or AWS can do it. Okay. So again, sometimes project may people will say, why to do all those headache manually? Let's use a AWS service which is going to deal with Redis related setup. Okay. So just be aware. I think Elastic Cache is that service where we can set up Redis. Okay. Setting Redis in AWS. Yeah. So one of the option, the way RDS is one of the service, using that you can set up a relational database like MySQL. Similarly, AWS is providing something called as Elasticache. And using this Elasticache service, you can do Redis setup. So if you just go to AWS and you search for Elasticache here, Elasticache. Using this Elasticache service, you can set up a Redis software as well. Okay, get started. Let's say you do this get started here. And now Redis, these are other type of caches, memcached, okay, valkey. So they have given multiple types. Now you can choose, I want to go ahead with Redis. And then there are some multiple set, okay, backups. And there are a lot of settings which will come here, which will help us to make a proper Redis software. But just be aware, okay, one of our common practices, developers try to avoid doing all this because scaling, backup, clustering. So we focus, let's go ahead with application related work and use AWS for all these additional things. Okay. So again, the more you use these kind of softwares, it is going to cost you more. So because it's running in a cluster, it is making high availability. So generally for our testing purpose, we generally don't go in all these things. In production, we might run with a cluster, but even in non-prod environment, we don't set up in clusters and all those things. We generally might take a simple approach, only one Redis instance, and that too running inside our EC2 machine itself. That is a cost-saving solution. It makes it functional. But in production, when you are going, you might choose a properly scaled up, high available Redis instance. So looking at the cost factor, people have to decide what approach they want to take forward. Okay. Sometimes clients will say, it's okay. Okay. Even if you are not going for cluster for Redis, non-prod may still use Elasticache itself. But again, these decisions are project to project, and looking at cost, amount of complexity, people have to make that decision. But two primary options are there. One of the option is you can use AWS Elasticache itself. The second option is you can directly install it on EC2 machine. Okay. And this is easy to do the setup. It is cost saving. You are already paying for EC2 machine. If it has one more software, you don't have to pay anything additional for that. It's just IO, how much IO you are using, but it will be very small depending upon your testing that you are doing. Okay. So please be aware, for Redis setup in AWS, as a service option is available, which you can go for Elasticache for Redis, or second is directly install on EC2. So depending upon cost and other factors, this decision will be taken care. Okay, again, one-time setup will happen. We will be directly setting it up on EC2. Okay, so but just be aware of these namings. Okay, yes, that option is going to be available. From Java perspective, it works the same, regardless of whether you're setting it here or whether you do it here. You will get some details like where it is connected, what port it is running. Default port will be 6379, and whatever password is set up, you will be getting those details. Okay? If you're running it in EC2 machine only, here you provide localhost. If you are running it on Elasticache, it will give you some IP. You need to use that IP. So accordingly, right, depending upon your setup, these values will change from environment to environment. So every time you need to ask this question, for this environment, what values are applicable? Okay, for this environment, what are the applicable values? But anyways, our decision is in EC2 machine, we want to install Redis so that our Spring application can directly connect with it. Okay, how to do that? Some simple commands are available. You can go to ChatGPT and say, this is my Linux machine. So for example, okay, which is our Linux machine? We installed this one. We can just give the instructions. Okay, it has, oh, it already read our somehow Amazon Linux 2023. So how to install there, it has given steps also. So install Redis 6. So by this way we can install. By this way we can start the Redis. By this way we can enable on boot. Nothing but whenever the machine is restarted, Redis is going to be up and running. And you can just connect using this kind of a command. And then you can execute further information. Okay. So let's try to run this command as it is. Okay. So this is our EC2 machine. We are still connected. We can run this command. Okay. Installation is happening. It is saying completed also. Next, you can start the Redis software using this kind of a command. Okay. On boot up, you want to start. Every time machine is restarted, you can do this. Okay, that is created. I think they have something called as status also. Okay. So whether it is up and running, we are able to see that. Active and it is running. And 6379. And it is taking request from current machine. Just notice this. It is taking request from current machine. This IP 127.0.01 specifies it's the current machine. From the current machine, okay, on this port, it can take some connections. But fine, it is working. Next, you can do a ping like this. Let's try to see. First, we will connect to Redis CLI. Redis CLI. Okay, Redis CLI command is not available. Let's try to tell it to ChatGPT. Redis CLI command not found. Okay. I think here, since we are installing the Redis version 6, these commands become Redis 6, I guess. Let's try it out. Yeah. So since we are installing Redis version 6, so your Redis CLI tool also becomes Redis 6-CLI. Okay. So just be aware. Depending upon your software version, sometimes these kind of things are available. So I will just paste it here. So this becomes your Redis CLI. Let's do a ping here. Yes, we are getting connection back. Nothing but it is able to connect. You can do now select 0. All your Redis CLI operations, whatever we did on Redis day, remember, yes, it's available. You can do keys. Yes, it is available. So Redis is there running on the machine. We are able to access it also. So guys, that work is completed. let me paste these commands, whatever we used via ChatGPT. But again, it was very much straightforward. We just used it. Okay. So connect to the machine, and then this one. Connect to EC2, and then first you install, then you start, then you enable, and then you can do even status. History command is going to show you this. You can give the status also. Okay. After that, you can do Redis CLI, and yes, it works. Okay, Redis CLI. So this is how we installed Redis in EC2. Okay, but please be aware, project might use Elasticache. The way RDS is one service which is managing MySQL, like that, Elasticache can manage your Redis as well. Okay, fine. Okay, so we are done with this setup. Guys, are we clear so far? Everybody, are we clear so far? Okay, Shubham is clear. Guys, whatever questions you have, write it down. Later on, explore it on internet. Okay, work with internet, work with ChatGPT, get your answers clarified from there. Okay, chalo, let's continue further. Now the next thing, we need to again resume back with RDS. We need to resume back with RDS. Okay, so we saw it here. RDS is available. So with regards to RDS, we need to set up DDL and DML here. Set up DDL and DML here, because without that, our application cannot run. So our steps for that will be connect from local machine. So right now we are doing this approach. DB Weaver itself we will use, and we will try to connect to AWS RDS from local machine. And after that, we will be executing DDL and DML. So let's do that. So we go here, click on this DB. Generally, somewhere we should find those details. Connectivity and security. How to connect to this? Multiple options are there. We can choose using endpoint option. Just check it out. Using this endpoint from your local machine, you can connect to this database. Okay, using this endpoint. So what did we do? We went to that database, connectivity and security, and using this endpoint, we are able to copy this, go here, create a new connection for MySQL. Now point is, one is local database. Now one we are trying to connect to AWS cloud. You just need to specify that I want to connect here. Okay, you just specify I want to connect there, and using 3306. Okay, okay, fine. And just test the connection if everything is okay. Okay, access denied. Credentials we need to update as per what have you set up. Okay, credentials you need to set up properly. And yes, the connection is happening. So that's our next step. From local machine, we need to connect to that AWS RDS. This is how we do it. Okay, create new connection. From RDS screen, we got the endpoint that needs to be added into the server host. So that is how we can connect from local machine. DB Weaver, take RDS endpoint and set up in new connection in DB Weaver. Okay, test the connection and now save it. Test and now save it. So here we go, we say okay, and we do finish. Fine, this is how it is available. Let's open the connection. So we can just expand it. Connection is open. Create a new SQL script. The new SQL script, okay. And now just observe, there are multiple database. One is local, one is dev. If you have QA, you will have third QA also. So you need to be careful which database is picked up here, because whatever queries you write, it will go in that database. Okay, so you need to be careful that in this drop down, you need to have the correct database selected. Okay, so let's make a note of that. So start new SQL script, ensure correct DB is available in drop down. Nothing but be connected to the right one. Otherwise, you are putting somewhere else. Okay, fine. This is done. Next, let's run our scripts. V1. You copy this. You go here. Select all. Execute. So it executed. Okay. So the database should be available here. Right click. Refresh. So this is just a warning message because the first two commands says drop database if exist. So for the first time when you run it, the database does not exist. So it is just giving that information. It does not exist, so we cannot drop it. So it's just information output, and you can do a right click, refresh, and expand this. Yes, the DDL is created. Next, DML we need to do. V2. You take this one, copy, come here, execute, go and run. So by this way, DDL, DML, both of them are set up. Select star from validations dot, let's say validation rules. Yes, we have the two rules. And next, select star from validation rule params. Yes, we have the parameters also set up. Next, select star from request. Okay, currently no request, but the DB setup is completed. Okay, so we have the database also installed. So what was our approach for DB setup? First, we connected to that by properly taking the endpoint, and then we executed our scripts there, and yes, it is now ready. So RDS Redis we installed in the same EC2 machine. Next, this one also RDS is running in some other RDS service on AWS. Okay, fine. So let's try to correct our diagram. Based upon our current scenario, this EC2 machine is having Redis installed. Here itself, Redis is available inside the EC2 machine only. And secret manager, currently we have not set up. RDS is a external service right now. What is an external service? Outside your EC2. RDS is not running in a EC2 right now. So please be aware. I think we can move it here, and let's put some naming. It's already, name is lying here. So this is Redis, this is Spring Boot, this is EC2 secrets manager, and this becomes your database. Okay. So far, what setup is done? So far, we have completed this, EC2 and these two. Okay, guys, are we on the same page? Please mark your understanding score, guys. Okay, good, Priyanshu. Please mark your understanding score, and let's resume further. Guys, everybody, please be focused, because when you run projects, a lot of services will be there, and we need to have that kind of setup in the environments. So as a developer, you need to know what is going to happen. Your microservice will talk to which other systems. That basic awareness, every developer should have it. Otherwise, confusion will happen. right? You cannot even debug if you don't know where you are connecting, which Redis you will go for checking whether the data is loaded or not, right? So you need to know what services are working in which environments, and generally ask it to your team members, because every time every project might have something different. So just discuss it. Hey, where is this, where is that, how are you connecting, what kind of software are you guys using here, because they might just choose differently. Okay, fine. Almost everyone, 5s and 4s, that's awesome. Let's continue further. Okay, now comes our next point. RDS is ready, Redis is ready. Let's make application side changes. Okay, so our next aim will be application side changes. Nothing but Spring Boot application we need to change so that it can connect with these other places. Okay, now we are deploying it in dev environment. So what do we need to modify? Dev profile file, not local wala, right? So remember the profile concept, application-dev.properties needs to be modified because we are deploying in the dev environment. Every environment will have its own IPs and configurations. So now we are working with dev environment. Accordingly, we need to do the setup. Okay, okay, fine. Chalo, let's go further. Now we will come to this place. Let's visualize. While doing the configuration, RDS, this one we need to set up. Redis in the local host itself, it is available. Accordingly, we have to do the setup. Okay, fine. Now let's make it possible. So we go to dev property file. Let's see what changes we have. Nothing. We have never deployed validation service in AWS, so we have not made any changes. So currently, if you take this project and deploy there, basically nothing is going to work because configuration itself is missing. So we are supposed to take everything from local and go inside this place, all the keys and all the values. Step number 1. Step number 2, you have to customize all the values to be environment specific wherever applicable. Okay, so let's say my test key, so this is coming from dev property file. Next, where is your dev database? So if you say localhost, it means on this EC2, when your Spring Boot application is running, RDS is also here. That means localhost. But currently RDS is outside. So localhost cannot go there. RDS is outside. Localhost cannot go there. So what needs to be specified is, okay, your details about RDS. Here, this endpoint needs to be set up in your application. Nothing but how are we connecting to RDS? We are connecting using this endpoint. So that endpoint needs to be set up here instead of localhost. The port remains the same. The logical database remains the same. The username password remains the same, because in our this v1 scripts we use the same: create database, validation user, and passwords. So accordingly we are setting it up in our property file as well. Okay, now they can make sure this db user, okay, so this password we can anyways put it outside. So that is what is AWS secret manager related, but that changes we will do later. Currently, let's use this one without secret manager. Again, like incrementally we are working, right? So we will build this, deploy it, test it once. Later, we will add secret manager changes. Then we will be done with even that service. So currently we are putting it here. The username is this, correct? From the script we can confirm, and database is also like this. So these two things we can confirm, this and this. Okay. One thing will also be here, okay, this password, this statement, we will never commit such kind of statement also in the property file. Because if this goes into our code base, again, everybody knows the passwords. So it will also not be kept in the property file. Maybe this line externally, they will be setting it up. Okay. They might just create the database from here, create a password, create a user without specifying any password. Later on, externally log in and set up a proper password from there. Okay? So they can do all those kind of things, but please be aware, sensitive data is never going to be or should never be maintained in your code base. It should never be in no branch ever. Okay? Please be very strict about this. If you find it somewhere, you should raise it. Hey, can we remove it? Sometimes non-prod related people can keep it. Okay, production is a must know. Like you should never do production related. Non-prod may sometimes people compromise, but if possible, try to avoid non-prod also. So it becomes a habit for you. Okay, sensitive data should never be in your code base. Try it out. Okay, sensitive data should never be in code base. Try to check on this possibility. Okay, so what are we going to do? So we will come here. This is the DB that is correct. This is correct. This is correct. This is correct. Driver is the same. Currently secret key is the same secret key. So no need of any additional thing. Where is the Redis running? It's in localhost. So in AWS, in the localhost itself, Redis is there. So no need of any changes. Next, port is 6379 itself. No need of any changes. We have not done any password setup, and looks like default also, they don't have a password. If you enable the password there on the machine, then you can change it here. And there are some configuration files where you can edit the password. You can again ask ChatGPT and get to that configuration. Okay, I think these kind of files are available, Redis config and other places, how to enable password for AWS Redis. You will find some syntax and some files where it will be available. In EC2, just see, in this Redis 6, there will be some configuration file, and here you can enable the required password, okay, using require pass kind of thing, then restart Redis. So by that way, password can be set up. So any kind of doubts you are getting, you can go to internet and come up with some solutions. Okay, hey, there is no password. How do I set it? You will find some ways of doing it, and you can make that happen as well. Okay. Currently, we have not done the setup. Let's test it out. Okay, let's just continue with our changes. So no password, leave it empty. And this is local, and this is this one. Looks like the changes are fine. These changes are as per the AWS dev environment. Okay, all this property file. So dev.property, okay, make the changes as applicable in AWS dev environment. One by one, you have to check all the fields. Okay, is this correct? Will this data work in AWS dev? If not, you have to change it based upon environment. Chalo, fine, this is done. Next is what? Build jar file, which is dev environment specific jar file. We know the command for that. Maven package -p profile, dev profile. So we need to build that, and then we need to deploy it in AWS. For that, the command is scp, and then we have to start the service using nohup java space -jar, your service.jar, and then put the log somewhere, and then like this kind of command. In EC2, we discussed this. Try to recollect your knowledge. We need to build the jar file, deploy it using scp command, and then start the service. And then we have to do the testing. Okay. So these are our next actions. Let's go ahead doing that. So here we go. Right click, run as Maven build, clean package -p dev, and then try to run it. So this is the full command. Let the build happen. It will try to run the test cases also. Just see, it tried to activate the dev profile. So it read our configurations. Okay. While trying to run the test cases, it is trying to connect with the local Redis also. Okay, while trying to run the test cases. So since we don't have the local Redis running, we can skip the test cases. Okay. So these kind of things will happen. Sometimes you are trying to run or build for the environments. It will expect, the test cases will expect environment specific things to be up and running. But if you don't have it in local, those things will get into this test case failure. So in such scenarios, you can simply right click, run as maven build clean package -p dev, and then do a skip test. So please be aware, when you build for your local, you will have all the setup in your local machine. But if you're trying to build for environment, how can you have all the setup in your local machine? There is a very high chance your test cases will fail when you build it for environments. So what is a practice which people follow? When you try to build it for local, there you will not skip the tests. It will run properly. But when you are trying to build it for environments, you will just click on skip test. So the build happens without any test case execution. Okay? So please be aware of that, because you will not have the environment configuration in your local machine. Definitely your test cases will fail because it is trying to start the Spring Boot application. And it's not possible, right? If Redis is not running, it won't work out. So yeah, like this. So please be aware of this note. While building, default, it will try to run test cases. Okay. Now, SRC main Java, and this is the main test case. Because of this annotation @Spring Boot test, it tries to start the Spring container and it tries to then create the beans. If using those beans, let's say we are not able to connect to Redis, automatically Spring application failed. So please be aware, while the test cases are running, it is trying to activate the container, and if it doesn't find the configuration, application fails. So that is the note we are trying to make. While building the application, nothing but package command, default it will try to run the test cases. Okay. Now because of this, it tries to start Spring Boot container, all that container and beans. If any bean creation fails, then Spring Boot crashes. Okay. When you are trying to build for environments, let's say dev, QA, so automatically you will not have all connectivity in your local machine. So practice is, you can click, you choose skip test while building for environments. You choose skip test while building for environments. Okay. Otherwise, for local, you have to have the setup and run the test cases. Okay. Yeah. For local, this option, but for the environment, you can skip it. Okay, fine. Let's try to, we have done the building also. Okay, let's go here. Copy. Next, let's try to connect here. Okay. Follow this simple practice. Keep two tabs. Left hand side is your local machine. Right hand side is the AWS machine. So CD space. You need to use 2 backslashes. Okay. LL. Yes, we are in this place. Now SCP command and the PEM file you need to use. Okay. So I think our files are having that shortcut. Okay, SCP command. This is the jar file, and we need to copy it here on this place. 59182 is that machine. Yes, we changed the IP. So let's use this command and try to copy from our local machine Let's review the command quickly, guys. scp-i, where is your PEM file? Which jar file you want to copy? Where do you want to copy it? SCP source destination, that's the main syntax. SCP source destination. So this file, I want to move it here. Where? On this IP, as a user, EC2 user, this is the default user for your EC2 machine, and on this folder path. This is how you specify, and we need to do it in a secured manner, and then enter. Okay, the copying has happened. It's happening. Next, LL. We need to give override permission also. So let's give a override permission. LL. Now write permission is also given. So we can even copy the same file one more time as well. Okay, very good. Next, so jar is available there. Jar is available there. Next, we need to start this Spring Boot application. So this is done.